Okay, so section 4, we're going to be looking at exponents. For exponents, this is not only a short lesson, but it's more of rules rather than internalizing any concepts. And with rules, just like pretty much with anything, right? Practice, practice, practice. But these rules are just ones we have to keep in mind and practice them so that we can remember them. There's not much conceptualizing. Anyway, so let's get started. For exponents, we have our first rules here, our first 4 rules. We have the product rule, quotient rule, power rule, and power of a product rule. Now, those are the rules on the side. Again, maybe a bit easier if we look at examples. So first things first, we just need to remember what x squared means or what x to the third means, what exponents mean, basically. If we have x squared, all that means is x times x, right? You multiply x by itself 2 times. If you have x to the third power, you multiply x by itself 3 times, and so on and so forth. So let's go ahead and look at an example. The product rule, here we have 3 to the third power, or 3 cubed, times 3 to the fourth power. And our product rule is telling us if we're multiplying with the same base, then you can add the exponents, meaning 3 to the power of 3 plus 4. And well, 3 plus 4 gives us 7. But why? Why does that happen? Why does this rule exist? Or how do we know it's a valid rule? Well, we can rewrite 3 to the third power as 3 times 3 times 3, and 3 to the fourth power as 3 times 3 times 3 times 3. And as you can see there, it's just basically multiplying 3 by itself 7 times, so that's why we get 3 to the power of 7. So same base, if they're multiplying, we add the exponents. That is a product rule. Now, the quotient rule. Say we're to have now 4 to the power of 7 over 4 to the power of 4. Now here, bases do have to agree, meaning these numbers have to agree. Notice how in the rules we have a's, right? A here, right here, and a right here, right? This doesn't work if the bases are not the same. But when we're dividing this with the same bases, we can subtract the exponents. So this would equal 4 to the power of 7 minus 4. And again, why? Well, if you're to expand that out, we'd have 4 sevens at the top being multiplied in the numerator, and in the denominator, we'd have 4 fours multiplying. And what can happen there? Well, we have the same factors in the numerators as in the denominators, so we can cancel 4 of them out. What does that leave? That leaves 3 fours at the top being multiplied, or in other words, 4 cubed. Okay, now we're going to look at the power rule. So this you might have heard before as a power to a power. If you have a power to a power, in this case 5 squared cubed, we multiply the powers. So that would equal 5 to the power of 2 times 3. And that would equal 5 to the power of 6. Again, let's go over the reasoning. Why does that happen? If you were to look at this, 5 squared cubed. Well, 5 squared we can rewrite as 5 times 5. And then we have still this cubed, this power of 3, meaning rewrite that 3 times. So that would be 5 times 5, 3 times, which would give us 6 5s being multiplied. So if you need to pause and kind of see the reasoning and digest it, go ahead and do so. But a power to a power, we multiply the powers. And the last one is the power of a product. In this case, we have 2 times 4 cubed. So the cubed will apply to both the 3 and the 4. Careful. Students would, I've caught students saying we distribute the power. We don't distribute. This is not a distributive property, although it seems like one. It's just applying the exponent to the two numbers that are being multiplied. And again, why does that happen? Well, that's only, I left it as exercise, but I'll give you a hint here. Just expand it, all right? If you expand it out, you'll have 2 times 4 3 times, which will give you 2 to the power of 3 times 4 to the power of 3. So you can go ahead and try that out. But like I said, not much conceptualizing here. It's more of rules we're going over. And that is pretty much what the next slide is. In this case, our slide here, I just wrote them out in this case. Reason being is here we don't have much reasoning. It's just going over examples. So the power of a fraction rule in this case is we have 3 over 4 to the power of 3. And again, it applies to both the numerator and the denominator. So we have 3 to the power of 3 over 4 to the power of 3. And the last 3 rules are more of a definition. I don't have the reasoning for you. If you are interested in the reasoning and you're interested in becoming a math major, you can look into the theory in some of your classes as to why they're defined the way that they are. The zero exponents rule is anything to the power of 0 is always equal to 1. However, 0 to the power of 0, well, that gets a bit complicated, but I promise you they won't make you do anything like that unless you get into those math theory courses. But anything to the 0 power is just 1. These other two get a bit more interesting. When you have a negative exponent like we do here, 3 to the power of a negative 2, what happens there is they get sent to the denominator so that the exponent can become a positive number. So 3 to the negative 2 is the same as 1 over 3 to the power of positive 2. And well, 3 to the power of positive 2 is just 9. 3 squared is 9. So that is just 1 over 9. And the last thing, the fractional exponents. Here we have 3 to the power of 2 over 3. I'll rewrite it so it looks a bit nicer. 3 to the power of 2 over 3. What happens with this is, as you can see, the one in the denominator becomes the index. We call that number the index. In this case, we're going to have a cubed root because it's a 3. And then the 2, the numerator, becomes the exponent of the number inside, being 3 squared. And as you can see over here, the rule, it tells us exactly that. So there is memorization in math, and the easiest way to memorize is, I wouldn't say much practice with index cards. It's more like practice problems, and they become second nature. You remember how everything's supposed to, the rules for everything. But that's all that is for exponents. These 8 rules we need to practice to internalize them.